let's go ahead and go over this. So with these little number lines, it's kind of explains the graph of this one. Basically, it's always increasing. It crosses through 1, 0. So right there, it's increasing and down to start with, and then increasing and up. So basically, just graph like that. So increasing the whole time. It was down because it's less than 0 when it's less than 1, so it's down, and then it shifts to up. So, yeah. With the second part, you gotta get all the critical numbers first, which basically all of these are critical numbers. You have to set each one of these equal to 0, and so you get 1 is a critical number, 2 is, 3 is, and 4. Those are all your critical numbers. Those are all multiplied. So from there, you have to do like your sign analysis. So if we did like f prime 0, you start to get the hang of it after the first 1 or 2. It seems like, well, how are you going to do all that without a calculator? But you start getting the hang of it after the first 1 or 2. So you plug in 0, you're going to have a negative here. This is going to become positive. This would be negative because it's odd power. That's going to be positive. This is going to be power. So basically, you just count the number of negative signs you have. So with 0, again, this is negative because the first power. This would be negative, but you're squaring it, so it becomes positive. This would stay negative because it's odd power, and that would become positive. So you have 2 negatives out of all of them, which makes the overall and becomes a positive. If you try 1.5, evaluated that, well, this would be positive. This would be positive. It's always going to be positive. This one would be negative, right? Because it's going to be minus and it's on power. So basically, you only have 1 negative. If you plug this in, 1 negative sign, so this is going to be negative. If you plug in 2.5, think about how many negative symbols you're going to have. This is positive, which is bigger. This is positive. This is negative, right? Because it'd be negative 0.5 here. This is positive, so only 1 negative symbol. Maybe do 3.5. Positive, 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 positive. Everything's positive. 4.5. Positive, 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 positive. So we got 2 places where there's sign changes, increasing to decreasing, so that's a max. And there's no way to know the y values, so we can just say x equals 1. And then a min here at x equals. Let's take a look at the homework here. So we have to do 9, 10, 14, and 17 to 21. So 9 and 10, you had to graph the best you could without a calculator. Pull up those solutions here. So 9 should look something like this. It's like a half circle, basically. Your critical numbers, let's see. The biggest thing would be to identifying first the domain has to be between -3 and +3. You guys able to figure that out? Okay. And that's really important. And then we plug in bigger than that won't work. So that's what restricts it to here. X-intercept, plus or minus 3. For your critical numbers, are only 0. Yeah. Because anything beyond that 3, well, it's at the end point, so it doesn't matter. And then, so it's increasing to decreasing, and then, it doesn't like it showed this second bit of it. But it would be concave down the whole interval. It's like, I don't know what should be. I guess maybe the fact that since it goes through 0, 3, it has to be okay down. Hold on. I guess there's no way. I don't think you could draw it any other way, I guess. Did you guys get something to look like that? Number 10 had this sine and cosine one. There's a lot of work there, but the graph ends up looking something like this. Yeah, that's a lot. All right. Let's see here. X-intercept. There's two of them, 3 pi over 4 and 7 pi over 4. Y-intercept is at 0. First derivative here gives you critical numbers of pi over 4 and 5 pi over 4. Then we have increasing to decreasing to increasing. Relative max there, pi over 4 square root of 2. Relative min 5 pi over 4 negative square root of 2. Second derivative right here, which gives our inflection points at 3 pi over 4 and 7 pi over 4. It's concave down and then up and then down. If you didn't get all of that right, don't worry. It's a lot. Did anybody get it right? Did you get it right? How'd you do? I'll get that one too. That one's hard. It might take me like a half an hour to do it.
Yeah, I think I will teach because I was trying to figure out the tangent.
Yeah. I actually saw this little YouTube video yesterday that's kind of helpful. It was just in my suggested videos. And it was this math guy, I think he's a math professor somewhere. But it's basically, the video was to say that like it's okay to not understand stuff sometimes in math. It's okay to just be alright with not understanding it. So he suggested like if you're really stuck on something, like don't spend like, hours trying to figure it out, but just like, set it down, go do something, and come back to it later. He said, just to give an example, he said like, I think when he was going through like grad school or whatever, he was working on one problem for a week and he couldn't figure out like why he couldn't do this problem. Yeah, a week. And but then he found out there was a typo in the problem, so it didn't actually work. So the point was like, don't like waste your time on a problem that you're just not. Yeah. So anyhow. All right, and then the other ones we had were so like 7, 14, 14, and then 17 and 21. So on 14, going up. So you were stuck on the tangent line one, is that what you said? Well, you just use, it's a calculator question. So we can do derivatives on our calculators. So you would plug that whole thing in. Sine of and then two things you need to do. You need to find, well, if you're going to do a tangent line, we got our x, we need a y. So to find the y, you just do the table and plug in 5. And put that kind of fast, right? 73.924 would be your y coordinate. You need to get a slope. So it's be a good time to remember how to do a derivative on your calculator. Do you remember how to do that? So then you would just do the derivative at that point to get your slope. The slope then is 131.845. So then you would just write your y minus 73.924 equals 131.845x. And then 17 to 21. So BCAD. And then I guess 21. No, about 21 today. Here's all the slopes. This was kind of a primer for what we're going to do today. Estimating the slopes because we're going to try to do graphs. Any questions? Okay, so we're going to be doing this, again, this idea of estimating slopes. So, maybe not the easiest thing to do, but let me just go over some 21 here. So, I'm estimating the slope of like a point A. If you could just, I mean, you can't really see because it doesn't go through like an even spot, but find the next place where it goes through two even places, where it's down to over 3. So your slope there would be -2/3, right? Same with the B, this is a constant, so it would be the same, -2/3. C, obviously, the slope is 0. D is undefined. It's a little bit more challenging here, but you can see we're going down 1/2 and then over 1. So the slope here, what do you guys put for that slope?
I'll put the negative.
Okay, -1. So it wouldn't quite be -1 because they would have to be up here if it was -1. What is that?
I'll put negative 4 things.
-4 there.
So like also doing it, you get that. I'll put negative 3.
Okay.
If we go below that.
So I think the best way, okay, that works. It's a little bit challenging, figure it out, but that's what we're going to be doing today. We're going to basically be estimating these slopes with these tangent lines to draw graphs of the original function based off of the slopes. So, you're ready, here we go. All right, so there's not a lot of direction here other than we're going to try to take a function and either graph the derivative, or we're going to take a derivative, try to graph the original function, and also the second derivative. So let's start with this first one, kind of a warm up. We have the original function and we're supposed to sketch a graph of the derivative. So the easiest way to do this is basically estimate the derivative at all these places and then use that to plot them on the f prime. What I like to do is find all the places where the derivative is 0 first. So where are the places where the derivative is 0 in this one? So right here, the derivative or tangent line, right, is 0. It's a min or max. So at -2, and I just like to go ahead and mark a dot at -2, 0. It's good to know where you're going to be crossing the axes. This helps make everything easier. And then here we also have a tangent line of 0, so we know at +2 is also 0. So that's all. And then basically we're going to estimate the slopes at some points, and then plot those as points. Okay. So let's say here, -3. So right here, we're going to have to estimate the slope. That looks like it could be about 1 or so, right? 3. All right. So then what we'll do is -3, 1, dot. And we've already got the 1 in between there, so we can okay with that one. It looks like we're at -1 slope here. It's about -1, right? So then at -1 we'll go down to -1. At 0, looks like about the same, right? Still is about -1 slope. At +1, the slope is still about -1, right? So here. And then we're back up to 0, and then say at 3 here, it's about +1. And then we don't quite make 4. So. Then we're just going to basically connect the dots. So I think where you will see this on the AP test is like they'll give you a graph of like a function, and it'll say like which one of these could be a graph of the slopes, and you'll have to choose between like 4 graphs to see which one could be graph of the slopes. So on those, again, what I always try to do first is figure out where it's 0, and then there's a look at all the graphs and eliminate ones where it doesn't have the right 0 ones, because those are the easiest ones to find always. Look for the mins and maxes, and then you know where the slopes are zeros. That generally will narrow it down. All right, but the main thing we're going to be doing in this is we're going to be given a graph of a derivative, and then we're going to try to graph the original function. So kind of doing the opposite of that. This is technically a graph of what's called an antiderivative, which is what we're going to do in the next unit. Antiderivative is basically going from the derivative to the original function, so in reverse. So here's a graph of our derivative. The suggestion is to make some number lines. So look, we're going to take that approach here. We're going to make a little number line with this derivative, and then also make a number line with the second derivative. So let's do so. Here again, your just general instructions: make an f prime number line using the location or position of the points on the f prime graph. This does not involve the slopes of f prime. Now we're going to make an f double prime number line using the slopes of the graph. Combine the information of both. If no certain points are given, you are free to shift the graph vertically. A lot of words going on, but let's see if we can figure out something here. All right. So what values do you think we should put on this number line?
The zeros.
Yeah, put
Where-
these. Yeah, we're going to put those on the first derivative number line. So places where the derivative is 0. Because that's going to be helpful when we plot our original, when we plot f, because that's going to tell us where the mins and the maxes are, right? So where this derivative is 0, this I think is actually one of the more confusing things on the AP test, is like going from like derivatives to the original functions to the derivatives to the graphs. It can be confusing because you can kind of get in your own head thinking about what you're looking for. At least for me, that's one of the more challenging things. All right, so think about what this means. So these are places where the derivative is 0. So just don't really have exact points here, but basically like 3.5 essentially, negative 3.5 and positive 3.5. Kind of where we're starting and ending. And it's 0 at both of those, right? Which should make sense because it's not a continuous function. So what we're really looking for is this one, which is at 0. And then we want to just basically denote whether it's positive or negative in between those points. So between negative 3.5-ish and 0, is the function increasing or is it positive or negative? Right, it's positive. So here's where it gets confusing, because we're used to looking at the slopes of this, right? And say, well, it's actually increasing here and then it's decreasing there. But this is a graph of the derivative, so this just tells you positive values versus negative values for the derivative. So this means it's increasing this whole part and then it's decreasing that whole part. Okay? Second derivative graph, right? What types of things should we put on this one? Yeah, good. Yep, so we're gonna know what these places where the mins and maxes are, right? So yeah, -2, +2. Good. Yeah. So less than -2, we should put the endpoints on here again. You don't really have to put endpoints on here, but it's helpful. So from here to here, -3.5 to -2, the function is increasing, right? So it's positive. Ultimately, that tells us that it's concave up, right? I'm not even right. It's up, up. And then from -2 to +2, the whole way it's decreasing, so it's down. And then from 2 to 3.5 or so, it's increasing again, so it's concave up. So we have to combine that information to draw the graph here. And it says we have a starting point of 0, 1. So let's go ahead and put that 0, 1. And we're supposed to be increasing up to that point and then decreasing. Okay? It also might be helpful to know that there's a maxi, right? Maximum because it goes increasing and decreasing. Should make sense. Right, so increasing to decreasing, and then we also need to pay attention to the concavity. So at -2 and +2, it switches from up and then down and then back up. So somehow just make a note of it. It can be a little bit challenging to draw. You don't want to actually put a dot, but you need to make sure you change it from up to switch to down and then back up again. So it looks something like this. So it's concave up here. And technically, I guess we should stop it there and stop it. These can be challenging to draw. The good thing is on the AP test, you're not actually going to have to draw them because this will be a multiple choice question where again you're identifying which is the right one. So. Okay, the next one, we're actually going to try to draw both. We're given a graph of the derivative, and we're going to try to draw the original function and the second derivative based off of that one. So if we got a first derivative number line here first, what number should we put on there? Yep, -2 we're the only one we really need, right? So less than -2, it's negative, so that means it's decreasing. Greater than -2, it's positive, so that means it's decreasing. F double prime. What's a point that we want to put here? Yeah. So at 0 here, it's not really a min or max necessarily, but it looks actually kind of like it's undefined, right? Sort of that little deal going there. So it is kind of a critical number. Like I said, it kind of looks undefined, if you will. All right, so given that, what are we going to put on either side of that 0? So the slope is increasing here, right? Still positive. It's increasing, so it'll be positive. And also, kind of note that since we're going to be drawing the second derivative, what does it look like the slope is this whole interval here?
Positive.
Yeah, positive what? Yeah, it's just a positive 1 the whole way, basically, right? So the slope is positive, and it's basically, I'm just going to make a note of it. The slope is just 1, it's just a constant 1 the whole time, right? All right, and then it's still positive here beyond that, but. Okay, let's see if we can do the function first here. It doesn't give us a starting point, so there isn't really any specific one we have to do. We do know that at -2, that there would be a minimum, right? Decreasing and increasing. And it should be concave up the whole way, right? So, suppose there's a lot of restrictions here. You could just put really at -2, you could put the min essentially wherever you want, I guess. There's no restrictions. And then we just need to do decreasing and up, and then increasing and up. So, and probably actually what I would do, we're using, it's not. It is. It doesn't really matter. And the second derivative, so we need to sort of estimate this just like we did up here, where we did sort of these points, kind of take the same approach. So our only one sort of critical value is at 0, where it's undefined. So on all of these points, we said that the slope is 1, right? So that essentially means that the function value is going to be 1 on all of these. Let's see. Since the slope is 1 all the way up to 0, the slope is 1 all the way along here. So we're just sort of just putting dots. And -4 it's 1, and -3 it's 1, and -2 it's 1, and -1 it's 1. So this ends up just being like a linear equation, just kind of a straight line. But then it's undefined at that spot right there at 2. So you guys should just put a hole there. And then the slope is still increasing, but it's going to be increasing faster now. So now, actually initially, so change the line there. Initially, it doesn't increase quite as fast. It looks like maybe, yeah, so then it's going to start 0 and just sort of increase more and more there. It starts here and then it just sort of increases faster and faster. But it will be undefined there as well. It's not defined in either place. And then so it should just get bigger and bigger and probably just a linear fashion, right? Again, these are not easy to draw. And that's all the examples you're given, so good luck. All right, let's look at the assignment. You're supposed to sketch some graphs of the derivatives here to start. And then we're supposed to graph some of the original functions given the derivatives. So kind of both of those. And then we're supposed to do both. So let's do a couple of each of these as time permits. All right, so let's do like number one to start. We're supposed to sketch a graph of the derivative of the function there. You guys draw your own little. Okay, so what we want to do for this, we're trying to graph the derivative. So we want to estimate the derivatives at all these points. So like, let's, for example, just start at 0. So what would you estimate the derivative is here? There's a more scientific way to figure this one out. Because it's a linear equation, it's constant. What's the derivative at all these points? Yeah, it's going to be 3 because you can see from this dot to this dot, it's up 3 and over 1. And this is just a straight linear equation. So all of these would have a derivative of 3. So at this point, it's 3. At 1, it's 3. At 2, it's 3. So then our equation is just going to be basically just a vertical line of 3. Just saying that the slope is a constant 3. Let's try number 2. Number 3 should be pretty easy as well. Try number 2. So the one major spot I would get right at the outset is 0 here, right? The slope is 0 there at 1. Okay. So I would go to 1 and dot at 0. The slope is 0 at that point. And so here it's going to be decreasing. Here it's going to be increasing. So you can do that little number line like this suggested on this one. And put a dot at 1, sort of be our number line there. All numbers less than 1 are decreasing, right? So they're negative. All numbers greater than 1 are increasing, so it's positive. And suppose you could estimate again, like, so at -1 here, I guess you could say it's about negative 3 again. So like at -1, it goes like down 3 and over 1. So you could estimate a -1 is around -3. But there doesn't have to be one single graph, correct? We just need to know that it's negative, and then basically it switches to positive 3, and negative to positive. So you guys can do those other 2, 3, and 4. Let's try a couple of these. So we're supposed to now do the opposite. We're given a graph of the derivative, and then we have to do a graph of the original function. So this is going to be f this time. Starting point is 0, 0. So go ahead and put that on I don't think you probably need to even like do a little number line for this one. You could if you want to, but what point would we put on the number line? So this is the graph of the slopes. So this means here the slope is 0 right there. Okay. So at 0, the slope is 0. That's where it's crossing. Right. So any value less than 0, this is above the axis. So this is, again, this is the graph of the derivative. This means since this is positive, the slope is positive to the left of that. Okay? And then it dips below the axis, so then the slope is negative past 0. And so it's basically increasing to decreasing. And this has to be a max right there, right? Increasing, decreasing. So that's our one starting point. So it would just be somewhere like that. And let's do 7. So with our number line on this one, number 7, our points were 0 here. All right, -1 and +1. So less than -1, it's below the axis, so that means it's negative, it's decreasing. Above that, it's increasing, positive. And then it's back to decreasing. Our starting point is supposed to be -1, 2. Now we know we have a, think about mins and maxes here, decreasing to increasing, so that's a min at -1. And then we have a max at +1. So this has to be a minimum here at -1, 2. And then at +1, we should have a max. This is also what it is, but decreasing to increasing, back to decreasing. So, all right, now we're supposed to do both. Well, let's just try number 10. I think we'll only have time for one, so let's try number 10. All right, so let's tackle the original function first. We'll underline. So our places that we're interested in at -6, 0, +6. Less than -6, it's negative, so that'd be decreasing. And -6 and 0, it's positive, so that's increasing. 0 to 6, positive, increasing. 6 beyond, negative, decreasing. So this is going to be a min, and here's a max. We don't have a starting point, so and I'm just going to say this is -6 out here, +6 over here. So it just needs to be decreasing, switch to increasing, maximum back to decreasing. So,
graph is that?
Yeah, this is F. So it's decreasing on demand, then it's increasing the back. And then that's double prime. This is where you're going to want to estimate points. Two that you're going to want to put on the number line for this one are these zeros up here. And then some maxes. So like -4 and +4. And where it's 0, it's increasing, and then it's decreasing. Actually, sorry, I forgot one at 0. Increasing, decreasing. I don't know, but.
Bro, stop! Wait!
Alright. So, yeah, we need to try to get up through number 11 for one day. Do your best on those. There isn't one right answer on most of these. Notice it says a possible graph. So